Okay, this is a little tutorial about converting units, and we'll be talking as examples with metric units, and for metric units we'll typically be talking about the kilo, and then the base unit, and then milli, micro, and nano. And if you have one of these, a kilo is 1,000, and it could be meters, it could be grams, it could be liters, or it could be molar or moles per liter. These last two units might be the most confusing, but we're just working right now with prefixes, and it doesn't matter what the base unit is. A kilo is 1,000 of them. 1 kilo molar is 1,000 molar. Then down here, milli is 1,000th, or 10 to the minus third, or 0.001, and micro, 1/1,000th, a very small amount, and a nano, 10 to the ninth, a billionth. And I won't write all those out. There's an easy way to think about these, and that is there are placeholders around the decimal. So if we had 1 meter, this would be 999 meters, and this would be 1,000 meters, or 1 kilometer. So the kilo placeholder is there, and then we can go down the decimal point, and this is where this is helpful, because for 1,000 units below the decimal point, these are milli. So a milli is 1,000th, and if we have 1 millimeter, it looks like that, and that's 10 to the minus third, or 1 over 10 to the third, and we can count up to get 10 and 100 and 999, and 1,000 milli of anything is 1. Then these are the three placeholders for micro, because a micro is a millionth of the unit, but it's also 1,000th of a milli. So that fills in these placeholders. So you could have 999 micrometers, add one more, and you have a millimeter. And then this is nano, same story, down in the 1/100000th. And just like we go up above the decimal point, down below the decimal point, this is the thousandths, the millionths, and the billionths placeholder. So those are the units we're going to be dealing with. And there would be a conversion table provided typically, but we'll talk about that in a minute. And then the questions will be like this. How many grams in 100 milligrams? And so it's asking us to convert from milligrams to grams. And there's an equation. The basic equation looks like this. There are going to be 4 numbers involved, and we can just put in numbers like this. So this is going to be what we start with always, and it's 100 milligrams. And this is what we want, and it is X number of grams. And then what we're going to do is we're going to multiply it by a fraction, and in that fraction what we're going to do is we're going to put the unit we want to get rid of on the bottom, because when we multiply it through we'll have milligrams over milligrams and they'll cancel. Then we want to put the unit we want on top, in this case grams. So I'm just going to rewrite that with the numbers in. So we start out with 100 milligrams times a fraction in which the units are going to be milligrams, and grams is going to equal X grams. And now we're going to plug in some numbers, and what I do is I pick the big unit and I say, what if I had one of those? How many milligrams would we have? And the answer is we have 1,000 milligrams in 1 gram. And what we've done there is we built a ratio, a fraction of 1 over 1. And that's equal to 1. And a person can always multiply an amount by 1, and it will get the same amount. So we're not doing anything tricky here. We're just building a fraction of 1 over 1, but we're using different units, so we're going to plug in different numbers. I always pick the big unit as 1, because then the small unit would be a big number. There is a 1,000th of a milligram in a gram, and conversion tables often represent that. And so in the conversion table, I'll say 1 milligram is 10 to the minus third gram. It's a really small amount. And I don't like working with small negative exponents, and so I say let's pick this one as 1, and then we'll always have lots of the smaller unit. I do that because I'm a biologist. I'm almost always working in smaller units. And so we plugged in the numbers and we just multiply through the math, and we get the answer that 100 milligrams is equal to 0.01 grams. And if we just we went back to that placeholder thing like this, so we have a value like this, and milli is here, so what 100 milligrams looks like is that, because it's 100 milligrams, and we can just leave it like that and say 100 milligrams is 0.1 gram. So that's just a kind of a check, and it's really nice to have a check on these conversions because the units you're not familiar with, and it's nice to have a check to plug it in. This is the main equation to keep track of, like that. And it doesn't matter if we need to convert milligrams to grams or molar to molar. Here's something that's a little different, though, is when we're converting milligrams to another prefix, like, say, micrograms. That's harder because conversion tables always compare milli to gram, and we're trying to compare milli to micro. And so I'm just going to make up an example of that. So we could say how many micrograms in 10 milligrams. The best way to do that is just to do the problem in 2 steps. And in the first step, we say, oh, I've got 100 milligrams, and I'm going to convert that to grams, like that. And so I'm going to go to grams because from the conversion table, 1 gram is 1,000 milligrams. And when I multiply that through, I get 10 milligrams is 0.01 grams. Then, as a second step, we'll convert grams to micrograms because the conversion table has that kind of a value. So we're going to now go and get rid of micrograms. So put them on, or microgram, put them on the bottom, gram on top, equals x grams, like that. Oops, sorry, milligrams on top, grams here. Let me just do this over. How many micrograms in 10 milligrams? Okay, so we'll do it in 2 steps. 10 milligrams times a fraction that's going to have 10 milligrams on the bottom, grams on the top, equals how many grams? And we'll pick 1 gram and 1,000 milligrams, and we get again the same answer as before, 0.01 grams. Now we're going to convert 0.01 grams to micrograms. So now we put grams on the bottom, we put micrograms on the top, equals how many micrograms. And we pick the big unit again. 1 gram is equal to 10 to the 6th, or 1,000,000 grams. And when we multiply that through, we get there are 10,000 micrograms in 10 milligrams. And we can do that placeholder again like this. We can go, that's 10 milligrams. I'll just write it out like that. Okay. How many micrograms is that? Well, there's micrograms, and there's your answer. It's 10,000 micrograms. Okay, and again, I'm doing this just as a check. It's a different way of thinking about it. If you learn this equation, you can solve any of these. Then the next kind of problem is where you're asked to do 2 conversions. So it's like how many grams per liter are there in 10 milligrams per microliter. Okay, and so we're asked to do 2 conversions, and we're going to do it in 2 steps. We do our first conversion, we'll convert from milligrams to grams. So we got 10 milligrams times our fraction. We're going to put milligrams down here, and we're heading toward grams, equals Our answer here is going to be grams per liter per microliter, because we haven't changed that microliter yet. We can put that here. So we're not going to change that in this equation. And now we just need to plug in numbers. In a big gram, there are 1,000 little milligrams. When we do the math, we're going to cross these off, and we're going to have grams over liter, and we'll have 0.01 grams per microliter. Then we're going to do a second step, 0.01 grams per microliter, and now we're going to get rid of the microliters. Microliters are on the bottom, so we're going to put microliters on the top of this equation, and we're heading toward liters, so put that on the bottom, because we're going to get grams per liter out of this. So x grams per liter. And in 1 liter, there are lots of microliter. You see how it doesn't matter whether these numbers are on the bottom or the top of the fraction. They're always positive values, and we just plug them in. And when we multiply this through in this case, the microliters will cancel, and we'll have 10,000 grams per liter, like that. And just thinking if that's right. Million more. Yeah, I think that looks good. And so that's changing 2 units at once. Then the next thing to mention about is this idea of molarity. And molarity is equal to moles per liter. It's a unit of concentration. How many are there? How many of a number are there in a volume? And a mole is a certain number, in the same sense that 12 is equal to a dozen. Scientists came up with a definition of a mole in the same way, and it's a big number, and that's because there are always lots of little molecules dissolved in solutions in biological samples. And so we don't need to work at this number at all, because we've defined it as a special name. And 1 molar solution is 1 mole, this many of those per liter volume. And we can work on some problems like that. We'll just first do a unit conversion just to show you that. You can say, how many millimolar are there in 10 micromolar? Okay, so here's a thing where we're going to do this in 2 steps, because we got to go from micromolar to molar, and then from molar to millimolar, because the unit conversion tables typically go from this to this, from this to molar, the base unit. And so we can write this out. We got 10 micromolar, and we don't need to understand what molar is. We're just using it as a unit. So 10 micromolar on the bottom there, and we're going to convert to molar on the top, and we're going to get to how many molar this is. And so 10 micromolar, and we've got 1 big unit and a million micro small units, and when we multiply that through, we get that how many molar in 10 micromolar is there are 10 to the minus 5th molar, or 0.1, 2, 3, 4, 5, like that. And we can do this placeholder, so that's milli, and then 10 micro would look like that. Okay, and that's our value. How many molar? How many of these are there? A really small amount, that many. 0.0001. Maybe I've got an extra 0 in there. And just looking back at that, thinking about that. So, okay, and so now we need to do the second part, which is we've got 10 to the minus 5th molar, and we are going to convert that to millimolar. So we're going to put molar on the bottom, so it will cancel when we do the math. Millimolar on the top equals, and we'll get millimolar out of the deal. And when we have 1 molar, we have 1,000 millimolar. And so our final answer when we do the math through is going to be 0.01 millimolar. And that's just showing you that molarity is used in the simple conversions in the same way. And in working with molarity, this is the first of 3 examples, and that is molarity problems can require what we'll call simple conversions, like this, same as we're learning for grams, liters, and meters. Could be molarity. Okay? Then the second one of the 3 is that we just need to learn that molar is equal to moles per liter. And we can switch back and forth through those just without any math, just by rewriting them. So you could have a question like this: how many moles per liter are there in 3 molar? Like that, okay? And in this case, you can just take molar and rewrite it. 3 molar is the same as 3 moles per liter. And in this case, you got your answer without doing any math. In other cases, it could say how many millimoles per liter are there in 3 molar. And the first thing you do is just that, that switch. And then you'd have to do the math. You'd have to convert from moles to millimoles. And you'd be all set. So sometimes number 1 and number 2 are combined. Sometimes you need to do this as part of the problem and then do a simple conversion. Then the final third example of molarity is when we need to make a recipe, because molarity was invented by chemists functioning like chefs in a chemistry lab and looking for shorthand notation, and used molarity as a way to help them make recipes. And for these recipes, we just need to learn one more thing, and that is that 1 mole of any molecule is equal to the molecular weight of that molecule. And we don't need to calculate that in our course. This will just be given. So for example, you could have a question of how would you make a 2 molar solution of glucose? And you'd say, well, what's the molecular weight of glucose? And the molecular weight of glucose is equal to 180. 1 mole of any molecule equal to 1 molecular weight in grams. Sorry. And so how would you make a 2 molar solution of glucose? Well, you need 2 moles, and 1 mole equals 180 grams. So to make a 2 molar solution, what you could do is weigh out 2 times 180, or 360 grams. So weigh out 360 grams of glucose, and then dissolve up to 1 liter in water. And you would have 2 moles. 1 mole weighs 180 grams, and 2 moles weigh 360, so you'd have 2 moles in 1 liter. And when I'm doing molarity problems, I always first calculate it as if I'm going to make a 1 liter volume. Sometimes the problem will ask you to make larger or smaller volumes. So how would I make a 2 molar solution of glucose? And it could be, how would I make a 100 milliliters of a 2 molar solution of glucose? And so what I need to do is I can calculate on paper how I'd make a liter, and then using unit conversions I can scale up or down to make that final volume. And we'll talk about this in class 2, but that's just a quick chalk talk about those topics for now.